Thank you so much for the kind introduction. Thank you, DCPC and IPMA for this opportunity. So we are APChemi, Agile Process Chemicals. Acronym is APChemi. We started in India and now we've moved our headquarters to Netherlands. The topic of the presentation is advancing the chemical recycling and how the innovation can help. So the problem that we deal with is this kind of plastic waste that is absolutely mixed, flexible, post-consumer plastic waste. A bit about us, these are the visuals from the projects that we have developed. So we are leaders in pyrolysis. We turn non-recyclable plastic, tire and biomass waste into value. We have developed over 47 pyrolysis plants that look like this. Since 2007, we have been doing this. We've transformed 179 million kilograms of plastic waste in over 1.3 million hours of technology performance. So there's substantial technology performance guarantee warranties that exist. We are supported by Shell Petrochemicals out of their Shell E4 platform. We are the only pyrolysis company supported by them in India. We've jointly raised $2.4 million along with Aalborg University Denmark and Plast Center Denmark as part of Plastic to Hydrogen Indo-Danish Green Hydrogen Research Fund. So we're working on that as well. We're working on up to 240 tons per day pyrolysis capacity projects in Europe and UK. Till date, the projects that we have developed have generated more than 3,000 jobs globally, and we have also recently developed more than 7 proof of concepts on chemical recycling, out of which 3 projects are operating at a commercial scale. We have 12 patents in pyrolysis and oil purification. We file only the enforceable patents that we can look at the plant and see whether the technology is copied or not. If there is something inside the reactor that we don't patent. So very enforceable patents we have in both pyrolysis and oil purification. We have 3 ISCC Plus certified pyrolysis plants already operational, wherein the post-consumer plastic waste is coming to these plants, getting converted into the quality of oil that is required by global refineries and petrochemical players, and the oil is getting sold in India as well as abroad. India around $800 per ton, abroad it goes up to even $1,200 per ton ex-factory. So the technology is operational at a commercial scale, including ISCC Plus certificates. So the issue is clearly that less than 10% of plastic waste is recycled, rest 90% goes to landfill or incineration. Incineration of plastic waste generates huge amount of carbon footprint. So from now to 2030, around 3.5 billion tons of carbon dioxide will go to the environment because of plastic waste going to cement kilns and waste to energy plants and incineration. Additionally, a huge amount of crude oil and gas is pumped out to make new plastics. So if you connect all problems together, it looks like this, that the crude oil is used for production of polymers. Then polymers are used by FMCGs, which leads to generation of plastic waste. Then plastic waste is either sent to landfill or it goes to the incineration or waste to energy plant, wherein the CO2 is emitted. There is pyrolysis technology that exists. If you convert plastic into oil, the quality issue of the oil is a problem, then that oil again is used as a fuel. So again CO2 emission happens. And since this pyrolysis oil contains a lot of impurities, this oil cannot be used by refineries for production of circular plastics. The way we solve this problem is that we convert plastic waste into purified pyrolysis oil using our patented technologies. Even if somebody else converts plastic into oil, we are able to purify it in our pyrolysis oil purification plant near Mumbai, and that purified pyrolysis oil goes to refinery and petrochemical companies for production of food grade circular plastics. We have 2 technologies. One is pyrolysis and second is oil purification, which is of equal or more importance. Our pyrolysis oil purification technology solves the core problem of pyrolysis oil quality with respect to the chlorine content. Our technology beautifully removes up to 99.7% of chlorine impurities, including from organic as well as inorganic impurities. Plus we are able to remove other halogens, oxygen, silica, metal, heavy metal impurities as well. If you compare our pyrolysis oil purification technology with other methods of purifying the pyrolysis oil, we are able to purify oil at a lower capex and opex, we are able to remove more impurities at a lower carbon footprint compared to distillation, adsorbents, or hydrotreating. We have validated our POCs. We have ongoing transactions with these organizations, and the oil is getting supplied to global petrochemical companies as well. In our pyrolysis oil purification plant near Mumbai, we take the contaminated oil, we purify it using our patented technologies, and then that oil goes to refinery and petrochemical companies for production of circular plastics. Some of the case studies, in Kenya, we have supplied a 10-ton per day plant that takes every day 10 tons of post-consumer plastic waste and converts it into a high-quality pyrolysis oil liquid using SCADA automated plant. We have supplied a multi-layer packaging pyrolysis plant for a conversion of MLP into high-quality liquids again. So we have very good capabilities of processing multi-layer packaging as well. We have our own pyrolysis oil purification plant near Mumbai, as I said. Now, when you do production of plastics from oil or gas, or compare that to oil from plastic waste, and when you look at the carbon footprint, the second line talks about the carbon footprint that gets generated when you produce plastics from crude oil or gas. There, the typical emission of carbon is somewhere around 1500 kilograms of CO2 per kg of plastic generated. We are able to reduce this carbon footprint by around 20 to 30% because our pyrolysis oil purification technology reduces the use of chemicals required for purification of pyrolysis oil. So not only that you produce circular plastics, but also produce circular plastic at a carbon footprint which is lesser than crude oil plastics as such. Our plants have 2 to 5 times more capital efficiency compared to rest of the technologies available in the market. We have not only pyrolysis but also have pyrolysis oil purification technology. And since we have pyrolysis oil purification technology, you can start with contaminated plastic containing PVC or PET and still produce good quality of pyrolysis oil that can go to a refinery. We bring in huge amount of ecosystem even internationally, so that even connecting for selling the oil would be easy. We have received multiple awards in this particular domain. So now I want to discuss few thoughts with you on how, as an industry, we should look at chemical recycling or advanced recycling, wherein plastic gets converted into oil and that oil goes to the refinery, and then refinery sells that out as a circular plastic to enable recycled content in food and pharma packaging. So one lens through which you can look at it is the scale. So if you see household level segregation, that is the grassroots of reverse collection chain of plastic carbon. Then comes material recovery facilities, then comes pyrolysis oil producers, pyrolysis oil aggregator. Compared that to the refinery scale is much higher. So typically one refinery probably can procure purified pyrolysis oil from 50 to 100 different pyrolysis and oil purification projects. So there's a huge difference in the scale at which refinery operates and these pyrolysis and oil purification plants operate. These are much smaller units compared to the refinery scale. And this also brings us one of the challenge that we've very closely seen, because we've been around since 2007. We had huge issues when the crude oil prices crashed in 2014 from $130, $140 per barrel to around $30 per barrel. And in today's term, the $140 per barrel way back in 2013-14 is like around 250, 60 barrels in today's terms. But actually crude oil price is going down. So refineries are protected against crude oil price fluctuations, but these smaller players are not that protected against crude oil fluctuation. And that is where, in case you produce pyrolysis oil that can go for circularity, there certain price protections are available, off-take prices are available for circular plastic producing pyrolysis oil. So that kind of gives the price protection in case you do pyrolysis for circularity. If you don't do pyrolysis for circularity, if you do plastic to fuel, then your business is completely subjected to crude oil price fluctuation. A second thought is the value chain of advanced recycling. It's probably the biggest value chain in case you look at the recycling as such. When you do mechanical recycling, there is no refinery involved in that. But in case you are refinery, or even to some extent, some other players also are not involved. Like you don't need to have cooperation from municipal corporation in case of mechanical recycling much. But in case of chemical recycling, top left-hand side, there is pyrolysis plant. Pyrolysis plant needs to produce oil that has to go through pyrolysis oil purification technology. Purified pyrolysis oil has to go to petrochemical players, and petrochemical players are actually of three types. So one is the monomer producer, second is the polymer producer, and third is the chemical producer. In places like Singapore, monomers and polymers are produced by separate companies, but in India there are certain complexes where everything is done by a single player. So these kind of nuances also are there. That's where also we bring in our expertise. Then comes packaging companies who need to design the packaging so that it is easier to recycle. FMCG companies need to also design the packaging which is easier to recycle. Then comes consumer, plastic segregators and all. In case of chemicals business, margins are like 5 to 10%. So unless everybody in the value chain cooperates, that margin doesn't come. And that is one of the bottlenecks that we see in scaling up the advanced recycling. So we are only able to pluck some low-hanging fruits, but the whole industry is yet to adopt that cooperation wherein a refinery, lets go of its huge ego because of the size and collaborates very closely with smaller pyrolysis players that we don't see as of now. It does happen in case we get involved because of certain relationships that we have, but that close cooperation across the value chain doesn't exist right now. So it's the chemical recycling is at very early stage. It is probably at 0.5% of its potential, what it can be in another 10 years. This is another thought that I would like to leave you with. In this chart, there are two data points. One is the colors of the country, and second is the investments that is coming in chemical recycling. Darker the color, more is the mismanagement of plastic waste. And let's focus on India. India is in dark blue color. So what it is saying is that more than 80% of plastic waste in India is mismanaged. Now why is that? Because if you go to a municipal corporation, वो कचरा कहाँ पे भेज दिया, वो dumping ground भेज दिया. But dumping ground is not a scientific management of plastic waste or any waste. You need to have a scientifically designed landfill. Then it is considered as proper management. But most of the landfills in India are just open dumps, and that is why it is called mismanagement. In case of flood, all the plastic waste from landfill of Mumbai can get washed into the ocean. So millions of tons can go into the ocean in case of, so if you see huge amount of mismanagement of plastic waste happens in Asia and Africa alone. However, if you see the investments in chemical recycling, those are primarily happening in Europe, USA, North America and Australia. So there's a huge disparity between where is the need for chemical recycling and where the investments are happening. Most of the investments are happening in developed countries while the need is there in Asia and Africa. So this is another challenge that this industry is going through. Even though you can do much more amount of chemical recycling in the same capital in case you do it in India. So now I have got a couple of minutes, so I want to discuss one more thing. There is, as far as chemical recycling is considered, people think that in case you do chemical recycling, then jo circular plastic produce hoga, that will get produced at 2.5 times the cost. So it is, the end product is going to be extremely expensive for consumer, and because it is going to be expensive, the end product is going to be expensive for consumer, it is not good for business. So chemical recycling, it doesn't make commercial sense as such. So that kind of myth is there, which I want to dispel through this calculation, and happy to share this presentation, and you can calculate and verify what I am going to discuss here. So if you consider a typical packet of chips, which is having say 200 grams of potato chips in it, that will use 2 grams of plastic in production of that particular chips packet. I have considered the thickness. There are detailed calculations behind this, how many microns of BOPP, LDPE and all. So around 2 grams of 1.5 to 2 grams, let's say 2 grams of plastic is used for production of chips packet, which has an MRP of 92.5 rupees. So 5-6 brands I have taken an average. If you see the plastic that is used, for 2 grams, the cost of plastic will be 30 paisa. 0.3 rupees is the cost of plastic that is going into the chips packet. Now, in case we say that chemically recycled plastic, it need not be 2 times. I think the fair value will be 1.5 times. But even if we say that chemically recycled food grade plastic sell at 2 times the crude oil price, then in that case, rather than the plastic cost of 30 paisa, it will be 60 paisa per pouch of chips. So the cost is just increased, it is like 30 paisa per 92 rupees of chips packet. That is the only increase in the price of the end product. And if we see, if we pledge for plastic circularity via chemical or advanced recycling, just 0.3% of price rise is there, wherein, these FMCG companies or brand owners have multiple opportunities to increase the prices maybe 5% to 10% every year. In that 0.3% is nothing. So it's a myth that, chemically recycled food grade plastic makes things unviable commercially. So consumer impact is 30 paisa. I don't think consumers these days, whoever is buying chips packet of 92 rupees is worried about 30 paisa in that. So from business perspective also, we have to understand that in case your packaging has recycled content, if your food grade packaging has recycled content, your brand image goes up, and that itself kind of compensate for the 30 paisa that you spend on a packet of chips like this. There are a lot of things that linear economy doesn't consider into account. For example, when you use crude oil or gas-based plastic, you don't consider the environmental cost. So business में 30 paisa 0.3% is more expensive, तो कौन करेगा? But environment we don't care about much. So that consciousness is yet to come, which is coming up very fast in Europe because of stronger implementation and consciousness in general. In India, we have to have these kind of discussions, and thanks IPMA for these kind of discussions, that this kind of consciousness comes into everybody's business decisions. Very quickly, last 2 points. So second is that when we use plastic waste, there is already the carbon taxes in India are under discussion. So $80 per ton of emission of CO2 is already the carbon pricing. The plastic products that you produce, if the end product is going for incineration, then probably per ton of plastic you will generate 3.5 tons of CO2, which will attract around $350 of carbon tax. Now, that also you have to consider into account. If you don't do circularity, you are liable for carbon, you have to get into emission trading system because those laws are coming right now. And then penalties due to non-compliance is definitely going to be more than 0.3% of the product cost. So that also needs to be considered into account. So circular plastic via advanced recycling is viable, sustainable, and beneficial. It does require discussion, and then the way can be figured out. So thank you so much, and happy to stay connected and explore what can be done further. Thank you.